Hello everyone, welcome to the world of file systems. In this presentation, we will explore about different types of file systems, about their basic concepts, implementation, performance, and their security and future development. Let us discuss about these file system structure and implementation. The file system structure and implementation plays a crucial role in organizing and managing files on a storage device. Understanding how these file systems work is essential for efficient data storage and retrieval. Know more about these file system basics. The file system is a method for storing and organizing files and directories on a storage medium. Components include metadata, data blocks, directory structure, and the file structure, and file system operations like read, write, and delete. File system can be organized hierarchically such as tree-like structures. First of all, there is a hierarchical manner which is nothing but application program, logical file system, file organization module, basic file system, IO control, and devices. Know more about these file system. File system provide efficient access to the disk by allowing data to be stored, located, and retrieved in a convenient way. A file system must be able to store the file, locate the file, and also the return to retrieve the file. Most of these operating systems use layering approach for every task, including file systems. Every layer of file system is responsible for some activities. The image shown below elaborates how the file system is divided into different layers and also functionality of each layer. When an application program asks for a file, the first request is directed to the logical file system. Then the logical file system contains the metadata of the file and directory structure. If the application program doesn't have the required permissions of the file, then the layer will throw an error. Logical file systems also verify the path to the file. Generally, files are divided into various logical blocks. Files are stored in the hard disk and to be retrieved from the hard disk. Hard disk is divided into various tracks and sectors. Therefore, in order to store and retrieve the files, the logical blocks need to be mapped to the physical blocks. This mapping is done by file organization module. What is the purpose of the file organization module? It is nothing but to map these logical blocks and the physical blocks. It is also responsible for the free space management. Once file organization module decided which physical block the application program needs, it passes this information to the basic file system. The basic file system is responsible for issuing the comments to the IO control in order to fetch those blocks. IO controls contains the codes by using which it can access the hard disk. These codes are known as device drivers. IO controls are also responsible for handling these interrupts, which is nothing but it is a flow of program from writing the program which is in the application program to the connecting with the device drivers by using those IO input codes in the hard disk. There are different file systems and there are as follows. First one is the file allocation table, which are used in the older Windows systems, and the new technology file system used in the modern Windows systems. A popular file system for Linux-based operating systems is nothing but ext4 and HFS plus the hierarchical file system plus used in Mac OS. Other file systems include ZHS, ZFS, XFS, and BTRFS. The next topic is file system implementation. The file system is implemented at the disk level involving disk structure, allocation methods, directory structure, and file storage or retrieval techniques. Disk structure includes partitions, sectors, and some blocks. And in those blocks, there are boot control block, volume control block, file control block, etc. And let us know more about these. What is nothing but a boot control block, volume control block, and file control block. A boot control block is nothing but it contains all the information which is needed to boot an operating system from that volume. It is called boot block in Unix, and in NTFS it is called partition boot sector. Next one is volume control block. Volume control block contains all the information regarding that volume, such as number of blocks and size of each block and the partition table, pointers to free the blocks and free FCB blocks. In Unix, it is known as super block, and in NTFS, this information is stored inside master file table, which is nothing but directory structure as per the file system. A directory structure contains file names and pointers corresponding to FCBs. In Unix, it includes encode numbers associated to file names. The next one is file control block. File control block contains all the details about the file, such as ownership details, permission details, file size, etc. In UFS, this detail is stored in code. In NTFS, this information is stored inside a master file table as a relation database structure. A typical file control block is shown. Till now, we have discussed about these data structures that are required to present on a hard disk in order to implement these file systems. And these allocation methods determines how the files are stored on the disk, such as continuous, linked, or index allocation. Before discussing about these performance and optimization, let us know what is meant by file system, which is used to organize and store data in the format. So these performance can be affected by some factors, and we can use some techniques to increase its performance. Let us know about those factors which are influencing the performance and optimization of the file system. File system performance can be affected by factors like disk fragmentation, caching, and I/O scheduling. Techniques for optimizing the performance include defragmentation, prefetching, and intelligent caching. We will explore the case studies showcasing real-world file system optimization strategies. And the last topic in this session is about these security permissions to the file systems. File system security is vital for protecting sensitive data from unauthorized access or modifications. File system permissions control who can read, write, or execute files and directories, which is nothing but every file can have those read, write, executable permissions, which can be authorized so that uh, a person can read or write or execute that particular file. Some files can be only for read only purpose and there is no write purpose. So these permissions can be handled by using these file systems. Access control list offer fine-grained control over permissions. Encryption ensures the confidentiality and integrity of the data stored in the file system. Last, in conclusion, let me summarize all those topics which we have discussed in this session. And in this presentation, first, we discussed about what is meant by the file system, which is nothing but used for organizing and storing the data, and also different types of file systems like FNTS and HFS Plus for Mac OS, and in modern Windows, which file systems are used, and also the hierarchical manner of application program, logical file system, file organization module, basic file system, I/O control devices, how the flow continues, and what is meant by those individual steps like application program where the users write the program, and logical file system which contains the logical block numbers, file organization module which connects the logical blocks and the physical block numbers, IO control which generates a code for accessing of the device drivers. And next we discussed about those performance and optimization techniques and file implementation. In that file implementation, we mainly discussed about these disk structure in which it contains different blocks like boot control block, file control block, etc. And some security permissions. Also, we discussed about read, write, executable permissions of those particular files. And future development in file system technology continue to push the boundaries of storage efficiency and reliability. Thank you for going through this video and listening to this presentation. Thank you, ma'am.